In this lesson, you will learn to identify lines that are perpendicular and to write equations of perpendicular lines. We are going to graph two sets of equations on a coordinate plane. So our first set of equations is y equals 1/3 x minus 5 and y equals negative 3x plus 7. So given a coordinate plane, when we graph our first equation, we have a y-intercept of negative 5, so we will plot our first point on the y-axis at negative 5 and use a slope of 1/3, so rising up 1 and to the right 3 and making another point, and continuing to use the same slope, up 1 over 3 to the right, make another point, and we'll make our line. And then with the other equation, y equals negative 3x plus 7, we have a y-intercept of positive 7, so on the y-axis, plotting that point at 0, 7. And a slope of negative 3 would be rising or going down 3 and to the right 1 and making a point. Continuing to use that same slope, so down 3 to the right 1, make another point. And for good measure, I'll make another point and draw that line. And so there are the graphs of both of those equations. And so let's look at another pair of equations. So y equals negative 3/2 x plus 6 and y equals 2/3 x minus 2. So given a coordinate plane, on our first equation we have a y-intercept of positive 6. So on the y-axis at 0, 6, make a point, and a slope of negative 3/2. So going down 3 and to the right 2 and making a point. Continuing that slope, making another point, and drawing that our line. And then with the equation y equals 2/3 x minus 2, so we have a y-intercept at negative 2, so at the point 0, negative 2, and a slope of 2/3, so rising 2, so up 2 and to the right 3, making a point, and continuing with that slope, up 2 over 3, making a point, and then drawing our line. So what do you notice about the lines? Are there some characteristics that you can see about the relationship that these lines have with one another? And hopefully that you can see that these lines, when they intersect, the angle that those lines make is a 90-degree angle. So each of the angles when these lines cross are right angles. And so that's what we can tell from both pairs of those equations. So then we also need to look about what happens with these equations. What do we notice about these equations that would make these lines what we call perpendicular lines that have angles of 90 degrees when they intersect? And one thing I want to point out to you is we're still looking at the slope. So we know that with parallel lines we have the same slope, but when we're looking at perpendicular lines we can see something different about the slope. So in the first equation our slope is 1/3, and in the second equation our slope was negative 3. So we'll kind of come back to that here in a moment. On the second pair of equations our slope was negative 3/2, and then we have a slope of 2/3. So we can notice that in each pair we have a slope that is positive and a slope that is negative. And same with this pair, we have a slope that is negative and a slope that is positive. So that is one of the features, is that we have both signs of slope, so they're opposite signs. And then we also can notice here that we have 1 divided by 3, or 1/3. And we can also write 3 as 3 over 1. And similarly on these pair, we have a slope of 3/2 or negative 3/2 and a slope of 2/3. And so we call these opposite reciprocals. So that is a characteristic when we're talking about perpendicular lines, that our slopes are going to be opposite reciprocals. So perpendicular lines intersect to form right angles. The slopes of perpendicular lines are opposite reciprocals. And one other way to check if your lines are perpendicular is that if you find the product of your slopes of the two equations, that product is -1. So we're going to go through and determine if the following pairs of lines are perpendicular. So looking at the equations, y equals 3x minus 7 and y equals 1/3 x minus 9. So we're going to focus our attention on the slope. So both of these equations are in slope-intercept form. So our slope is our m, or our coefficient of x. So in our first equation, our slope is 3. And in our second equation, our slope is 1/3. So when we're looking at our slopes, we need these to be opposite reciprocals. So remember, the reciprocal is when the numerator and the denominator are in the opposite position. So those flip essentially. So if we have 3/1, we would have 1/3. So that's the reciprocal of the other. But then we also need for them to be opposite. So one should be positive and one should be negative. And since both of these are positive, those are not opposite reciprocals. They are reciprocals of one another, but they're not opposite reciprocals. So these are not perpendicular lines. Looking at the next pair, we have y equals 2/3 x plus 3 and y equals negative 2/3 x minus 5. So the slope of our first line, both of these equations are also in slope-intercept form. So our slope of our first equation is 2/3, and the slope of our second equation is negative 2/3. So we see that one of them is positive and the other slope is negative. So they are opposite signs, but then we need them to be reciprocal. So 2/3 and 2/3 are equivalent. Those are not reciprocals of one another. So these are not perpendicular lines. In the next pair of equations, we have y equals 5x minus 2 and y equals negative 1/5 x minus 6. So once again, both of our equations are in slope-intercept form. So our first slope is 5, and our second slope is negative 1/5. So recall that the slope of 5 can be written as 5 divided by 1, or 5/1. So 5/1 is the reciprocal of 1/5, so that it would be true. And then we need to check to make sure that they are opposite, so that one is positive and one is negative, which that is also true. So these are perpendicular lines. So let's look at another pair of lines and determine if these lines are perpendicular. So if we have the equations 4x minus 2y equals 12 and 4x plus 8y equals 24. So neither of these equations are in slope-intercept form, so we are going to convert them to slope-intercept form before we can determine the slope. So if we have the equation 4x minus 2y equals 12, and we are isolating y, we want our equation to be y equals mx plus b, we would subtract 4x from both sides. And so then our equation would be negative 2y equals negative 4x plus 12. In our work to continue to isolate y, we need to do the inverse operation of this multiplication of negative 2. So we are going to divide both sides by negative 2. And remember that you need to divide both terms in the numerator by the term in the denominator. So negative 4x divided by negative 2 would give us a positive 2x, and positive 12 divided by negative 2 would give us negative 6. So our equation would be y equals 2x minus 6. Looking at the other equation of 4x plus 8y equals 24, we would subtract 4x from both sides, and our equation would be 8y equals negative 4x plus 24. Divide both sides by 8, and so we would have negative 4x divided by 8 would be negative 4/8x, so we could simplify that to negative 1/2 x, and then 24 divided by 8 would give us positive 3. So our equation would be y equals negative 1/2 x plus 3. So now that our equations are in slope-intercept form, we can draw our attention to the slope, or our coefficient of x. And so in our first equation, our slope is 2, and in the second equation, our slope is negative 1/2. So we are continuing to look to make sure that these are opposite reciprocals. So a slope of 2 is the same as 2 divided by 1. So 2 divided by 1 is the reciprocal of 1 divided by 2, or 1/2. And to also check to make sure they're opposite. So we have one that is positive and one that is negative. So these are perpendicular lines. we are going to work to write an equation in slope-intercept form of a line perpendicular to each of the following lines. So given the equation y equals 1/4 x plus 7, we are going to write an equation that is perpendicular to this line that also has a y-intercept of -10. So since this equation is in slope-intercept form, we are going to draw our attention to the slope, which in this case is 1/4. And we need our slope to be perpendicular to this line. So our slope has to be the opposite reciprocal. So since this slope is positive, our perpendicular slope is going to be negative. And then the reciprocal is we are going to reverse the position of the numerator and the denominator. So our slope in this case would be -4/1, or that's the same as -4. So our equation would be y equals -4x, and we also said that our new y-intercept would be -10, so that becomes our b in our equation. Looking at the next equation, y equals -2x minus 1. We have our slope of -2. So we need to find the slope of the line that would be perpendicular. So the opposite reciprocal would be a slope of +1/2. And our y-intercept would be a +5. So our equation would be y equals 1/2 x plus 5. Determine the slope of a line that is perpendicular to each of the following lines. So in this situation, we are only trying to determine the slope of a line that is perpendicular. So if we have the equation y equals 4/3 x plus 15, our equation is in slope-intercept form, so our slope in this case is 4/3. So we are just trying to find the perpendicular slope. So we would need the opposite reciprocal. Since this slope is positive, we know that a line that is perpendicular is going to have the opposite sign, so our slope is going to be negative. And then the reciprocal is reversing the placement of the numerator and the denominator, so our slope would be -3/4. So we have a slope that is positive, a slope that is negative, and we can see that our numerator and denominator have changed positions. In the equation 2x plus 5y equals 25, this equation is not in slope-intercept form, so we need to convert that to slope-intercept form before we can determine the slope. So we would subtract 2x from both sides, and our equation would be 5y equals -2x plus 25. We would divide both sides by 5, so y equals -2/5 x plus 5. So now we can see that our slope is -2/5. And so if we want the opposite reciprocal, since this slope is negative, we know that the slope of a perpendicular line would be positive, and we are going to reverse the position of the numerator and the denominator, so we would have a slope of +5/2. And lastly, if we have y equals 5x minus 4, this equation is in slope-intercept form, so our slope is +5. So recall that 5 can be written as 5 divided by 1, or 5/1. So when we're finding the opposite reciprocal, this slope is positive. So we know that our slope is going to be negative, and then we are going to reverse the order of our numerator and denominator. So we would have a slope of -1/5. Write an equation in slope-intercept form of a line perpendicular to y equals 4x plus 12 and contains the point 8, -3. So here are some steps to follow. So the first step is to determine the slope, which is the m from the equation in slope-intercept form. So given our equation, we have y equals 4x plus 12, and we recognize that our slope is 4. So our second step then is to determine the slope of a perpendicular line, and remembering that that is the opposite reciprocal. So if our slope of this equation was +4, then our opposite reciprocal would be a slope of -1/4. So this slope then is what we are going to substitute into point slope form and then convert that equation into slope-intercept form. So we are going to use the formula y minus y sub 1 equals m, and in parentheses x minus x sub 1. So the equation for point slope form. And we are going to substitute our slope of our perpendicular line and our point into this equation. So when we do that, we would have the equation y minus negative 3 equals negative 1/4, and in parentheses x minus 8. We would simplify that step, and we would have y minus negative 3 is the same as the opposite of negative 3. And then we also need to distribute the negative 1/4. So negative 1/4 times x, and then negative 1/4 times negative 8. So when we do that, our equation would be y plus 3 equals negative 1/4 x plus 2. We still need to isolate y, and so to undo this addition of 3, we would subtract 3 from both sides of the equation. And our equation in slope-intercept form would be y equals negative 1/4 x minus 1. So what I want you to do now is to look at these sets of problems, work them out on your own, and when you are finished working those out, then push play on the video to check your answers. So pause the video while you work out these practice problems, and then push play when you are finished. Okay, let's see how you did. So the first set asks to determine the slope of a line that is perpendicular to each of the following lines. So given the equation y equals negative 7x minus 1, we have a slope of negative 7, which can also be written as negative 7 divided by 1. So if we're looking for the opposite reciprocal, that would be 1/7. Given the equation negative 12x plus 2y equals 8, we need to write our equation in slope-intercept form, so we would add 12x to both sides. We are left with 2y equals 12x plus 8, divide both sides by 2, and our equation in slope-intercept form is y equals 6x plus 4. So our slope in this equation is 6, which is equivalent to 6 divided by 1. So the opposite reciprocal would be negative 1/6. And lastly, y equals negative 2/3 x plus 9. This equation is in slope-intercept form, and our slope is negative 2/3, and the opposite reciprocal of negative 2/3 would be a positive 3/2. So write an equation in slope-intercept form of a line perpendicular to y equals negative 1/3 x plus 5 and contains the point negative 5, negative 1. So recall our steps to follow was determine the slope, which is the m in the equation in slope-intercept form. So the equation was y equals negative 1/3 x plus 5. So the slope was negative 1/3. So then our goal is to determine the slope of a perpendicular line. So the opposite reciprocal of negative 1/3 would be a positive 3 divided by 1, or 3. So we're going to take that slope and substitute it into point slope form and convert that equation then into slope-intercept form. So in point slope form, our equation would be y minus negative 1 equals 3, and in parentheses x minus negative 5. We could also write that as y plus 1 equals 3, and in parentheses x plus 5. So eliminating that double negative, or that opposite of negative. We would then distribute the 3 to both terms in the parentheses. So our equation would be y plus 1 equals 3x plus 15. We would subtract 1 from both sides, and our equation would be y equals 3x plus 14.